Hello and welcome to this episode. In this video, I'm going to give you a short introduction to how to calculate gradients using PyTorch. And from the previous videos, I kept mentioning that two key selling points for PyTorch is about the fact that it has support for GPU acceleration, so that if you have a GPU hardware on your computer, you can take advantage of it to accelerate all the calculations that you'll be doing on your vectors and matrices. And the second selling point is the fact that it also has automatic gradient calculation. Of course, these 2 points are pretty much standard in most of the deep learning libraries out there. But the third selling point for PyTorch is the fact that it is very Pythonic. It doesn't do a lot of magic. And so for me, PyTorch is in the middle ground between having something that is too low level, like the low level APIs of TensorFlow, and something that is too high level, like what Keras also gives to us. But for learning purposes and for understanding sake, I feel PyTorch is a good choice because it gives us a good balance between having something too low level and having something too high level. Of course, I've also mentioned that as a deep learning engineer, you don't need to have a favorite library. The libraries are tools for your work, so you don't specialize in a tool. Instead, you specialize in understanding the concept, and whichever tool you're supposed to use is going to largely depend on the team you are working with. And what wouldn't go wasted is your understanding. But if you specialize on a tool or a library too early, then you are disadvantaging yourself in the sense that you might not be able to work with certain people. Okay, that said, let's come to the focus of this video. I'm going to show you how to calculate derivatives of scalars, and the reason why I'm just limiting this video to derivatives of scalars is because the next video that will come after this is going to show you how to build a linear regression model from scratch using PyTorch. And in such a model, we don't have to deal with a lot of vectors. And so I'm not going to introduce how to calculate partial derivatives of vectors. I want to introduce the concept as and when we need them, so that you don't learn something and you'll be wondering how you're going to use it. Instead, I want to teach you the theory, and then we have a practical session where you will see how to use everything. So I'm focusing on scalars because the next video is going to make use of them to show you how to build a linear regression model using PyTorch. Okay, let's import Torch, and I'm going to import numpy as np. I'm not going to use it, but it's a habit I've built because you don't know when you're going to need numpy in your work. That is how versatile it is. Okay, so let's create a tensor. So I'm going to call it t is equal to torch.tensor. I'm going to put a number, let's say 3.0 in there. Okay, so this is how you create a tensor that has only one item. Right, let's see what is available on a tensor. And these are lots of attributes, some of which are functions, some of which are properties that you can access on a tensor. And so these are too many. I just want you to see what's available out there, and also learn how you can do that. So if you call dir on any value, it is going to show you all the properties that are available on that particular value. Okay, and for more explanation on how to use the AutoGrad feature that comes with PyTorch, visit the PyTorch documentation and go to the AutoGrad, which is automatic differentiation page. It has more details about what you need to know. Okay, all right, so out of these many attributes that you are seeing on the tensor, there are two of them that are key when it comes to calculating gradients. And the first one is a property called requires grad, which is requires gradient. And the next one is grad. Okay, so now we have a tensor. This is the tensor we created from the previous step. We can check if this tensor requires grad. T dot requires grad, and let's see what it says. False. And then let's see T dot grad, and it doesn't print anything. So the first thing I want you to take note of here is this property requires grad. Once you set requires grad, you are telling PyTorch to keep track of all the operations that you perform with this particular tensor. And once you are done with the operation, you'll be able to call a function on the resulting tensor. That function is called backward. Once you call backward, you are telling PyTorch to unroll all the operations that have been performed on the tensors that requires grad set to true. And once you have called backward, it is going to evaluate the gradient with respect to all those tensors for you. I know this is a mouthful and it is quite difficult to understand, so let's use an example instead. So I'm going to create a tensor x, and I'm going to put the value 2 in it. So tensor, and I'm going to set the value 2. I'm deliberately going to make a mistake here so that then I will explain to you why it was a mistake, and then I'll show you how to correct that. So I will set requires grad to true and see what Torch tells us. PyTorch is telling us runtime error, only tensors of floating point data type can require gradients. So if you want PyTorch to keep track of all the calculations or the transformations that you perform on a tensor and be able to calculate the gradient for you in the end, then the requirement is that that tensor must be of the floating point data type. And in the previous video, I explained to you that in deep learning, you usually want to restrict yourself to at most 32-bit floating point numbers, but it's also okay to use 16-bit floating point numbers and sometimes even 8-bit floating point numbers, depending on the target hardware on which you're going to run your model in production. That said, let's fix this issue. So you just have to set data type to torch.float32, and this should be fine. Okay, so now we have a tensor that has only one item in it, and so that makes it a scalar tensor. We have 2 in it, and we have set that requires gradient is equal to true. What it means is that at some point we will want to calculate the gradient of some resulting value with respect to this x. Let's create that resulting value. Let's call it y, and let's say y is equal to 2 times whatever is in s squared. Okay, sorry, I forgot my equal to. Okay, so now y is equal to 2x squared. If you know anything about calculus already, you will understand that if you have a function whose definition is equal to 2x squared, then the derivative of that function is going to be 4x. Don't worry if you don't know anything about PyTorch. I'm sorry, about calculus. The reason why PyTorch has AutoGrad is for people like us who are not masters of calculus. So don't worry if you don't understand how I came about 4x. I just said that so that in the end, when PyTorch shows us its answer, we will know that indeed it did the correct thing. So if you calculate the derivative of a function which is defined as 2x squared, you get 4x. And so if I evaluate the derivative at the point where x is equal to 2, like we have here, then I expect that the value is going to be 4 times 2, which is equal to 8. Let's see what PyTorch produces for us over here. So to be able to calculate the derivative of the derivative of y with respect to x, we need to call y dot backward. So I'll say y dot backward. Now, you don't see anything happening, but what happens internally is that PyTorch kept track of the fact that X required grad. Okay, so because requires grad is set to true on X, and we used X to perform this calculation of the Y value here, PyTorch kept X, it kept track of it, and once you call y dot backward, PyTorch is able to unroll whatever operation you performed with X, and it is able to calculate the derivative for you. How do we get the derivative? Now that we have called y dot backward, the way to get the derivative is we can say x dot grad. Let's see what that produces. So you can see that it produces a tensor with only one item that has 8 in it. So that is exactly what I said. And if you know calculus, you will know how to manually solve this. If you're not interested in getting the tensor output, you can say s.grad.data.item. So the data attribute on a grad is actually the tensor, and because the tensor contains just one item, from the previous video I showed you that if you have a tensor that contains just one item, you can call .item on it to retrieve whatever is in there. So now you can see that we have 8.0 over here. So this is what I wanted to show you in this video. This is a very simple demonstration of how to calculate derivatives of scalars. It is a bit different in terms of what you pass to backward if you are calculating the derivative of vectors. But like I said, because the next video is not going to make use of anything that requires calculating gradient of vectors, I'm limiting us to scalars because I want to introduce the features as and when we need them. So I'm going to take a recap. The first thing you do to be able to calculate the derivative of a tensor is to set the property requires grad to true. And then you use it to perform whatever transformations or calculations you want to do. At the end, you call backward on the resulting tensor that is produced after you have done all your transformations. Once you call backward, PyTorch is going to unroll all the operations, and it is going to calculate the partial derivative. I mean, in this case, it's just going to calculate the derivative of the resulting value with respect to all the tensors that had requires grad set to true. And then you can call .grad on any tensor that had requires grad set to true to obtain its gradient. This is the simple flow. One more thing you can check is x.grad fn, which is also a property, and you can also do y.grad fn. I will explain this. So you can see that when I called x.grad fn, it didn't show anything, but when I called y.grad fn, it showed mul backward 0 blah blah blah. This is how PyTorch keeps track of which operation created the tensor that you have called .grad fn on. So y here was created as a result of multiplication operation. That is why internally it is keeping track of the fact that we did some multiplication to come up with a value of y. And this is the mechanism that helps PyTorch to be able to unroll all these operations and then calculate our gradient for us in the end. When I called grad fn on x, we didn't get anything because x was constructed by hand. We created a tensor ourselves. It wasn't as a result of any transformation performed. In that case, x becomes a leaf tensor and y is not a leaf tensor. So thank you very much for watching. Don't forget to subscribe. Don't forget to leave your comments and questions, and I will see you in the next video.